Dear students, today we will discuss how to calculate the equivalent resistance when many resistances are connected in parallel, and we will also see what is the current division rule. So let's start. I am taking one circuit that is containing two resistances R1 and R2 in parallel. Suppose the current flowing through R1 is I1 and the current flowing through R2 is equal to I2, whereas the total current is I. Then from Ohm's law, I will write the value of I1 and I2. So from Ohm's law, I1 is equal to V by R1. Suppose this is the equation 1. Similarly, I2 is equal to V upon R2. Now I will apply the Kirchhoff's current law in this circuit. So before applying KCL, first we have to select the nodes. So I'm selecting node here. So from here to here, this is a single piece of wire. So this whole piece of wire will be considered by a single node. Similarly, downward also we will consider this as a node. So suppose this node is B. Now applying KCL at node A, we will write I is equal to I1 plus I2. Suppose this is the equation number 3. Now we will club these three equations. So from one, 2, and 3, what will happen? This equation can be rewritten as I is equal to the value of I1, which is V by R1, plus V by R2, which is the value of I2. Now we will take I common from both the terms, and this can be rewritten as V into 1 by R1 plus 1 by R2. This equation can be rewritten as I is equal to V by R equivalent. Suppose this is the equation number 4, where one by R equivalent is equal to 1 by R1 plus 1 by R2. This can be rewritten as R equivalent is equal to R1 into R2 divided by R1 plus R2. Now let's give this equation a number. So suppose this equation is equation 5. Now this R equivalent for two resistances can be calculated as the product of two resistances divided by the sum of two resistances. Now if we will generalize the equation 5, then if end resistances are in parallel, then equation 5 can be expanded till the nth term. So 1 by R1 plus 1 by R2 plus 1 by R3 till the nth resistance. So this will be your general formula for the equivalent resistance in case of parallel circuit, where this Rn is representing the nth resistance. Now, as we all know, conductance is represented by the symbol G, which is inverse of resistance, and the unit for conductance is the ohm inverse or mho. Ohm inverse or mho. So if we will convert this generalized equation, which is suppose equation 6, then this equation 6 can be rewritten as G equivalent is equal to G1 plus G2 till the conductance of nth element. So if you want to write the conductance of a parallel circuit, that will be equal to sum of the conductance of each resistance or each element. So now we will further move for current division rule. Now we will combine equation 4 and 1. So from equation 1 and 4, what will happen? This current I1, which is flowing through the resistance R1, is equal to V. That value of V is I into R equivalent divided by R1. And the value of R equivalent can be taken from the last equations. This I into value of R equivalent, that is R1 into R2 divided by R1 plus R2 divided by R1. So R1 will be cancelled out. So this current I1 can be written as R2 divided by R1 plus R2 into current, which is dividing in the parallel combination. Suppose this is equation 7. Now this equation is the current division rule, which is saying that the current in resistance R1 is directly proportional to the resistance which is in parallel with the R1 divided by sum of 2 into current which is dividing into the parallel combination. Similarly, we can write I2, this would be equal to the resistance which is in parallel with R2 divided by sum of 2 into total current. Suppose this is equation number 8. So these two equations are representing the current division rule. So these equations are representing current division rule. We can also write equation 7 and 8 in the form of conductance. So I am writing equation number 7. So first I am dividing this equation by R1 R2. So dividing equation 7 and 8 by R1 R2. So we will divide numerator and denominator by R1 R2. So this I1 is equal to R2 divided by R1 R2 divided by R1 plus R2 divided by R1 R2 into I. So this equation can be rewritten as I1 is equal to 1 by R1 divided by 1 by R1 plus 1 by R2 into I. Clear? So this equation can be rewritten as in form of conductance. So I1 is equal to 1 upon R1, that will be equal to conductance, divided by G1 plus G2 into I. Suppose this is the equation 9. Similarly, I2 can be written as G2 divided by G1 plus G2 into supply current I. Suppose this is equation number 10. Now, these two equations are also representing the current division rule in form of conductance. And it is saying that the current in any resistor is directly proportional to the conductance of resistor divided by sum of conductances into supply current. Now we will solve this problem, and in this numerical we have to calculate the value of I1 and I2 with the help of current division. So here we will suppose this is a resistor R1 and this is a resistor R2. Suppose this is the current I. Now we will apply the same formula which we have studied. So we have studied I1 is equal to R2 divided by R1 plus R2 into I. So we will put the value. R2 is here 5. So divided by 5 plus 10 into I. I is 15 here. So output will be equal to 5. Similarly, the formula for I2 is equal to, so this is I1, R1 divided by R1 plus R2 into I. This should be equal to, the value of R1 is 10 divided by 10 plus 5 into value of I, that is 15 again. So I2 is equal to 10 ampere. Now we will solve this numerical. In this numerical we have to calculate the value of I with the help of current division. So before applying current division rule, I will find the value of current through 1 ohm resistor. Suppose that current is IT or total current. So for calculation of this current, what I will do, I will calculate the equivalent resistance of whole the circuit for this voltage source, or you can say between this terminal and this terminal. So I will calculate the equivalent resistance of whole the circuit, which is equal to R equivalent is equal to these three resistances are in parallel in series with this. So R equivalent is equal to 1 plus 6 parallel to 3 parallel to 2. We already know that how to calculate the equivalent resistance in parallel. So equivalent resistance of this combination is, suppose R equivalent for parallel combination is equal to 1 by 6 plus 1 by 3 plus 1 by 2, which you will solve and you will get LCM will be 6. So 1 plus 2 plus 3, that is equal to 6 by 6 is equal to 1 ohm. So from here you will get R equivalent for parallel combination is 1 ohm. Now put this value here. So from here you will get R equivalent equal to 1 plus 1 is equal to 2 ohm. Then we will calculate the current IT, which is equal to 30, which is the voltage, divided by R equivalent, that is 2. So IT will be 15 ampere. Now we will calculate the value of I from the current division rule, that is equal to the conductance of the branch in which we have to calculate the current. So 1 by 3 divided by the conductance of all the branches which are in parallel with this resistor. So 1 by 6 plus 1 by 3 plus 1 by 2 into current into 15. So this will be equal to 1 by 3 divided by, so LCM will be 6 and this will also be 6 into 15. So this will be cancelled out. So current will be equal to 5 ampere. Now one more method you can try. What you can do, just convert these two resistors and make a combination of these two. So what it will appear like this. So this circuit will appear this like. So we are clubbing the 6 ohm resistance and 2 ohm resistance. So this is 30 volt. This current will be IT. This is suppose I. And the value of resistor is 3 ohm here. And this is the parallel combination of 6 and 2. So this will be solved 6 into 2 divided by 6 plus 2. So this will be 12 by 8. So 3 times and this will be 2 times. So 3 by 2. Now you have to calculate the value of I. So I is equal to the resistance which is in parallel. So this is 3 by 2 divided by 3 by 2 plus 3 into total current, that is 15 ampere, is equal to 3 by 2 divided by, this will be cross multiply. So 6 or 3, 9 by 2 into 15. So this will be cancelled out. This will be gone 3 times and this is again 5 times. So resultant will be 5. So in this manner you can solve any kind of problem with the current division rule. Now come on to summary. So what we have learned today: equivalent resistance in parallel, which calculated as 1 by R equivalent is equal to 1 upon R1 plus 1 upon R2 plus till the nth resistance. Equivalent conductance in parallel is the summation of all the independent conductances. In current division rule, we have learned that the current in resistor is directly proportional to the resistance which is in parallel with the branch which is carrying current I1 divided by sum of 2 into the current which is dividing into parallel branches. Similarly, I2 is equal to R1 which is in parallel with R2 divided by R1 plus R2 into I. You can also write this current division rule in form of conductance. So I1 is equal to conductance of that branch which is carrying current I1 divided by G1 plus G2 into I. In general, this formula can be written as I1 is equal to conductance of that branch divided by sum of all the conductances of parallel resistors into total current or the current which is dividing into parallel branch, where this conductance is inversely proportional to resistance, or it is the inverse of resistance. Thank you.